All right. Welcome to the next episode of Voice AI podcast, where we discuss the future of voice AI. Today, I'm really excited to host two amazing folks. Like, this is the first time I'm doing it this way. So, we have Quinn, who is the co founder and CEO at Daily. He has been multiple times on this podcast now. And we have Klemen, who is the co founder and CEO at Soniox, first timer here. Welcome, guys. Happy to meet you.
Thanks for having us.
Look, yeah, absolutely. Like we're going to discuss something very important. Something I think is the biggest problem with voice AI today, the accuracy of speech to text. But before we jump there, actually, I don't know if like there is a need for intro for daily, but I'm going to do it anyway. And then we'll also do an intro to Soniox. So Daily is a developer first real time video and audio infrastructure platform built on WebRTC, letting teams embed voice, audio, video calls, plus AI features into their apps. And Quinn is also the original author of PipeCat, which is an open source Python framework for building real time voice and multimodal conversational agents using pipelines that orchestrate speech to text, LLMs, and text to speech and transports. Huge fan of Daily, huge fan of PipeCat at Crisp here. And Soniox is a real time voice AI platform that delivers native speaker speech recognition, translation, and reasoning across 60 plus languages. Built on their own state of the art multilingual models, Soniox provides ultra low latency in region deployments and developer friendly APIs for powering voice products, agents, and global applications at scale. How was that? Was that accurate? Anything I missed?
I will just say that I was one of the originators of PipeCat, but it's a group effort and a big community. And I think that really matters that there are lots of great contributors.
Yeah, it's huge actually. Like there are many contributors today, right?
Yeah.
Yeah, and we are a big fan of Soniox as well. We actually use Soniox, we use Daily, and we use PipeCat at Crisp, and that's what sort of triggered this episode. And like I'm gonna give a backstory here. Like I was at VAPI, that was 2 months ago, and it was a great conference. Over 900 people showed up, developers. Great milestone voice AI. But like there was one thing that I was I kept thinking about, right? Like, okay, why is the voice AI traffic, overall traffic, not growing? And there is so much excitement around the space, but the traffic is not growing that much yet. And that sort of combined to what we see at Chris when we're building the voice translation, real-time voice translation product. And we kept sort of getting into this problem of transcription accuracy. And when transcription is not accurate, like things start breaking. In the voice translation, and to be clear, right, in the voice translation space, there is a human in the loop, right? There is always a human in the loop. So it's a two-side translation. But even in that case, if you start with something where transcription accuracy is not great, especially for B2B use case, right? Then like the whole conversation is gonna go south. And then in agentic voice space, like there's no human in the loop, hopefully, right? And then like the impact must be higher there. And then we started looking at Soniox, and we were like quite impressed with the speech to text accuracy, especially for like things such as emails, alphanumerics, and other things, which are super important for B2B use cases, especially customer service. And we were like, okay, we should be talking about this more. And let's actually get Quinn's opinion about this because he's seeing everything, pretty much every vendor, and he really likes like to prototype, demo, and through PipeKite, I think community just has access to everything out there, right? And let's talk about this problem. Like, let's understand how widespread it is, and then also get Clement's opinion on what it takes to fix these issues, right? So that's the context. I think with that, Quinn, if you can share your your insights, your understanding of the state of art in real-time speech to text, right? For agentic and other use cases, like where are we today?
I think the real time thing is a good place to start because often we see benchmarks of transcription models and they have word error rate numbers that don't necessarily map to what you end up seeing in your own use case. And there's a bunch of reasons for that. One is real time's really important. And if you have a very tight latency budget, you're going to be doing something slightly different than if you don't at the model level, at the infrastructure level, maybe in the loop you're building to do cleanup of transcription, which you can also do. Um, and we see people's use cases varying a lot. You were talking about how in some parts of the voice AI space, traffic isn't growing. I also think in other parts, you're seeing like a real invisible growth that just isn't quite as, as obvious yet outside. Like we're seeing a lot of call center workflows start to move to voice agents, LLMs. So what is it about the use cases that are growing, and what is it that's holding back the use cases that aren't? And we hear the same pain points you do, I think. So accents, making sure that not just for a few people, but for everybody, the transcription is accurate. Alphanumerics, addresses, the parts that are actually hard for humans too. If you're on a customer support call and you try to say your credit card number, it's definitely harder, even in a human to human call, to give somebody your
Yeah.
credit card number accurately than to just have the conversation. And then Clem and I were talking just a little bit before we started the recording about things like data privacy, compliance, having infrastructure in a region that's close to users and that and that is subject to all the rules around privacy. These are things we hear over and over that it feels like we're relatively early along in all the models in the stack, not just in transcription. And I would say that, I over and over hear from people with whatever model they're choosing, whether it's transcription or LLM or the voice generation models, they're trying to have really low latency, cost that is reasonable so that they can scale the use case, and quality. And you have to have all three of those. You can't just have, one of those be great and the other two, not be great. And so getting there on, cost, latency, quality all at the same time is like a big challenge for all of us building models and infrastructure.
Yeah, and just to follow up on that, Quinn, like other than if you look at, like, you probably see all these problems, and I agree with you. Like there are certain use cases, especially B2C, I would say it's probably growing faster. Like from that's what we see, right? It's growing faster because these probably these smaller issues don't matter that much. Like you don't have to, you know, get data from the end user all the time and get difficult data from the user all the time, like data extraction, things like those. But from what like the problem set you see, where would you put like transcription accuracy in that list, right? From like priority perspective, right? Is it? I always put it in the first place because that's where everything starts with. But is that the right way to think about it?
It's interesting. I think we might be seeing slightly different parts of the market, which is super helpful for me to hear about. I would put what I would call context engineering in the number one,
Mm,
sort of challenge getting from like a POC to production now. It's pretty easy to build a good proof of concept now for a voice agent. What we tend to help people the most with in both the open source kind of Pipecat world and commercially with Daily is you have that POC, you want to roll it out to a B2B use case. How do you make that agent reliable 99% of the time over a 30 or 40 conversation turn conversation? And the biggest tool we have is editing the context you're handing the LLM periodically, compressing in a smart way, picking out the right tokens for the subset of things you're trying to do at different points in the conversation. And that seems to be very high leverage. I actually think that the transcription stuff is almost the next thing after that for a lot of people because they get the first use case for one set of users working. And then they say, oh, well, I need to do this for a second language, or I need to do this for an environment where, you know, it might be noisier and there's less clear audio coming in for the models to work on. Or I need to do this for a multi-channel, like not just for the phone, but also for my web app. And so it starts to expand, and then you need better transcription. But I do think you can often get to that sort of first working, you know, 99% good agent with the transcription tools we have now.
And you think you can get there on the production scale, right?
We are seeing production B2B stuff
For
scale
English, I
quite a
guess.
lot.
For English, right? Mostly.
For English, yes, it's much harder outside of English. And I think that's actually a great thread to pull on here because Soniox is so
Yeah.
good at both other languages that aren't English and at mixed language, which is important for like a big subset of use cases.
Absolutely. Yeah, Clement, could you like share your thoughts? Like if you can describe what your technology, like the main technology is, right? The speech to text. And also if you can share your ideas on where you think the industry is from what you guys see, that would be great.
Yeah, sure. So, well, speech to text and accuracy of speech to text is, such a kind of overloaded word. Okay, and there's really a lot more to it, I think. And getting to a really high accurate solution of recognizing and understanding people when they speak in all kinds of real world situations is actually hasn't been that sufficiently well studied. Okay, speech to text as such has been really around for decades now, but um, in you know, I believe here at Soniox we really pushed an effort, a huge effort into how do we make this really work across languages, and how do we make real world use of this work. So, and accuracy is really it's as I said before, it's such a generic term. Like accuracy of what? Of general conversation, the conversation that we're having right now. I believe there are many tools out there, right, that are great at transcribing, such kind of audio. We're not really using much specific terminology. It's pretty generic conversation. But as soon as you turn into, perhaps education, right? You have a lecture about, physics, quantum physics, or you go to a medical domain where you have a doctor patient talking about medical things, then you very quickly get into domain specific things, right? Where general conversation, general accuracy is not very good. It's not a good metric anymore. It's really about how well can you recognize those specific, domain specific terms. So, and then to the voice agent, there are many things here again. Like one of the things that you guys have already mentioned is the alphanumerics, right? Letters, digits, phone numbers, addresses, zip codes, etc. Right? So those you do want to recognize really, really reliably, and um, and so and then there's the next dimension is like, okay, let's say you do recognize it well in one language, right? How do you go then across languages, right? So it's not just English, right? There are so many languages out there, and having like this speaker native, right? Because that's what you really need to make voice work. You need to have this speaker native accuracy for many languages, basically for each language individual, if you want to deploy a voice agent in that particular language or in that particular country. So that's the across language accuracy, right? And then the third thing is that you guys also brought up is how does this really work in real time with low latency? Right? We're not talking about async or batch or files. We're really talking about real time, low latency speech recognition, and you do need a different kind of technologies. You need streaming neural networks, inference infrastructure that supports this streaming low latency processing. um, and then you kind of get to basically what we're doing at Soniox. So we're really this basically one voice AI platform for every language, every speaker, all kinds of accents, super accurate across domains, including for voice agents in real time, low latency. So this is how I see like what's the core we're doing here at Soniox, what we're trying to solve.
I mean, is it like one model supporting all these use cases or the languages, or is it like different models?
Yeah, that's a great question. Yeah, we used to have separate models, but then we really realized that you cannot really learn enough from having separate models for each individual languages. So we made a big bet and went into the universal, basically one model for all languages. So underneath the Soniox API, this is one AI model that's powering all languages. And then what you end up seeing is insane amount of transfer learning. Okay, I would challenge, that even English itself is very challenging. When you start using words or terms that are not English necessary. Okay, if you're talking about names of the streets or names of the countries or cities or brand names that are not really typical vocabulary under English, you will see that English models suffer a lot. Actually, they misrecognize those very important entity names, even despite the fact that conversation is English. And when you try to automate flows, like with voice agents, you really do want to get those words correctly because they're crucial, right? So that's where we see like that. When you have one model, it's able to transfer all kinds of names and entity names from one language to another language seamlessly. It just basically emerges out of when you train a model like that, and you need to prepare data like that. So that's one. So that's there. Yeah.
And how do you think about the latency target? I always like to ask people, like, what is your goal for latency, and even how do you define latency for your model and your domain?
Yeah, Queen, that's an awesome question. Yeah. So again, yeah, what's a good definition of latency, right? I think the one that we use internally at Soniox is what is the time, what is the delta, the difference from the time that the word was fully spoken in the audio to the time the model predicts the word. Okay, so what is that delta? So once I have fully spoken a particular word, and when the model has fully recognized that word, what is the average delta for all words in a given corpora that you evaluate, right? So that is the delta. That's how we measure the latency on our side. Obviously, there are other latency, right? Like traffic latency, right? Network latency. So if you go across oceans, you're going to incur a couple hundred milliseconds of extra latency and things like that. But in terms of AI, machine learning, right? That's how we look at the latency. What is the target? The lowest, the better. But we do try to make a compromise with accuracy, right? If you're going to really push this delta down to the basically zero, or even try to predict before it was fully spoken, you're going to incur errors. So this is something on our side, on the model design, when we train these neural networks, the models, and we try to optimize for a value that is still low, still industry, like I would say one of the lowest, and extremely high accuracy. So we really do try to balance both of them. Yeah.
Yeah, I was playing with Soniox model. They have a really nice playground on the website. Also, you can compare it to other speech to text models, right? What was very impressive for me, and there are actually two things compared to the top model in the industry, even in English. When you go into alphanumerics and emails and addresses, it's just like day and night, and it's like, okay, that's what I mean, right? Like in B2B, especially in the customer service use case, like the address and zip codes, emails, alphanumerics come on every call, right? Because there is authentication, there is shipment, there's something. And if you can't get that right, how can the agent, like a voice agent, actually continue, right? I mean, it might ask again, that's fine, but again, because there is no human in the loop, that's what really caught my eye. And the second thing is this code switching, right? Also known as language switching, because I assume it's because one model that is fluent in these different languages, it can easily switch between languages. And in the Soniox model can switch between languages very easily, and that's very typical for humans, right? Not every use case, of course, but I use multiple languages in my everyday conversations, And that's I think that's very typical if you look internationally. So these are the two things that are that were super impressive for me. Yeah, I don't know. Quinn, have you played with Soniox?
Yeah, I
Or
really like the playground. Having good playgrounds is such a useful thing when you're trying to get a sense of how the models work. The other thing I try to do personally is just I have a lot of little PipeCat sample code things that are floating around in on on my laptop that I try to plug different models into an experiment. And I definitely agree that this sort of combination of latency, multilingual, in one conversation support, and the alphanumerics are super impressive.
Yeah, maybe to add to this, right? So I mean, what we're kind of really trying to do, right, with this speech to text that we're developing, like one voice AI for this language, for all languages, is basically remove all kinds of assumptions away that speech to text models or solutions currently have in place, right? So let me give an example, right? So when you go to let's say, for the sake, to ChatGPT website, right? When you type in, right, you can type in anything you want. There is no assumption, okay? You can ask it X, Y, Z. You might even make some mistakes, right? And basically, you will get a reasonable, human-like response back. So there's no assumptions really on the input, okay? And now think about what would be an appropriate or analogous solution, basically, for speech, for voice input. Like, it's actually really, really challenging. It's basically what we've built, okay? It is, I can speak about anything, so any topic, any word. I can speak in any language. I can switch if I want to. So you have to just remove all of those assumptions out of your AI model, to get to a kind of ChatGPT-like experience for the voice input. And I think that's what's really, really needed for the real world, to pick on voice AI. The voice AI really is, be, used a lot in all kinds of real world situations, not just in controlled lab-like or environments. So that's maybe a comparison that gives a good analogy here.
I'm curious how you think about the model you're building differently now that for these use cases, we're often sending the transcription directly to an LLM. As Avid said, there's no human in the loop. You're just kind of taking the audio input, you're doing something with it, and the next consumer and the most important consumer of that audio is a large, like a very large language model that has certain strengths and weaknesses. I think about this a lot when we're trying to kind of tune that last 5% of agent performance, because I always want to know that I'm giving the right tokens to the LLM if I can sort of figure out what those tokens are. So a couple of things I've wondered about, I'm curious how you think about the model is, as you said with ChatGPT, it's pretty accepting of a wide range of inputs. So for example, maybe the transcription model doesn't actually need to have accurate punctuation. You might want accurate punctuation for, the transcription you save for compliance reasons, or or if you're going to show that transcription to a user, you really want the punctuation. But maybe the LLM doesn't actually need the punctuation at all, and if you don't have to punctuate, maybe you can deliver the results faster. On the other hand, if you get little things wrong, the LLM is hard to predict at what it's good at correcting for and what it's not. You can often get some stuff wrong in the transcription, and the LLM will just figure it out, especially if you prompt it. In a lot of our voice agents, we prompt the LLM and we say, this is transcription input, ignore typical transcription errors, silently assume the right thing, all that stuff. But there are pieces where if the transcription is wrong, as you're saying, David, you really get off track, and it's hard to bring the conversation back on track. So how do you think about like the model designed more for LLM consumption than for human consumption?
Um, we still try to basically embed the audio, the speech, as accurately as possible into the text representation. And this speech to text, as I said, it's really a lot more harder, more complex problem than it sounds. And I think punctuations are actually quite important. Did I say really or really? Right? One is with a question mark, one is without the question mark. So intonation, right, and things like that are very much hidden in punctuations. and whether quotation marks are in place. Someone said quotation marks, right? So I think there is, I would say that an LLM would perform better with proper punctuation than without proper punctuation. Despite, I agree, you can prompt it, ignore all of those things. So so our job and the way we think about it is like to really, as accurate as possibly, embed audio speech into the text tokens, so that then downstream LLMs can do the most out of it.
So, Quinn, you mentioned the context engineering, right? I think what you mean by that is in the context of the use case. Let's say you're integrating an AI agent into a specific company. They have their own like company's knowledge, like tools and everything else. So how do you sort of determine what context to give to the agent at every step of their action, right? Like I think this is probably what context engineering is, and so from transcription perspective, though, there is context as well, right? How do you which is usually use case specific or industry specific? How do you see like these agent developers using today's transcription technologies to add this context to the transcription? I know like Soniox has certain like interesting ways of doing it, but what's the best practice today from what you see, right?
I would love to hear about what's coming next from these models, because I do think we can really improve the whole system here with the kind of system level thinking. What we see people doing today are a couple things. One is if you can tell the transcription API that certain keywords are likely to be in the context, that can help. We also can do a lot of prompting in the LLM stage to try to correct for those keywords maybe not being there or maybe being mistranscribed. That really feels like a hack, though, and I do wonder. I'm curious what Klemen could tell us is coming. Can we have the transcription model have much more context? Because one of the constraints that I think the transcription models have had when you try to run them in a very low latency real-time mode is they're mostly operating on pretty small chunks of audio. But a multi-turn conversation, you might build up many minutes of audio that are useful context. Is there a way to incorporate that long multi-turn context into the transcription stage?
Yeah, this is a great question, and I have some question for you. Context. I think there are two types of context, right? So at least one is okay. We're gonna start a transcription session, right? And we need to know some information. Let's say, like what are the names of the speakers, right? Maybe what are the names of the products, that are really specific, to this company or to this use case. If you're in voice agent space, whatever. So there may be some really highly specific things that there's no AI that would know about it unless you provide that information. The same goes for humans, right? When you go to a meeting, it really helps us to know who the people are and potentially what we're gonna talk about. Okay, so this is the context like that you can provide. Let's call it at the beginning of the session when you start a transcription session. And we have a very powerful context. I can talk more about this, but perhaps a bit later. So, and then there's the other context that Quinn referred to, like this multi-utterance context, right? Where the conversation keeps on going between an agent and a user. Let's say in this case, it's back and forth, and it can last for 10, 15, 20 minutes, or potentially something. Let's say on this order. In how do you bring all of this context in? So it really depends how you use, STT, like speech to text in this case. So you can potentially, transcribe both audios, right? You can transcribe the user that's, obviously you transcribe the user that's calling in, as well as the agent, which is the audio generated by the TTS. And nothing prevents you really in theory and practice to feed both audios in. And then in this case, the voice, the STT model will have context of both. And that's one way to provide full context over all the utterances in the conversation. This will give you the best results. And in this case, it's really important that you have voice AI models that handle multi-utterance, well across longer sessions, like that they don't, stop, let's say, understanding speaker or diarising speakers after 5 minutes or 10 minutes, but in fact they have this really large context in the background, that they can handle, and we support really long context on our side. So I think these are the two things that I see from the context perspective from the STT. But maybe a question for you, Quinn, is you said that there's a lot of engineering going into prompts and this. Can you tell a little bit more what you're seeing on your side?
Yeah, one of the things we're seeing quite commonly is using a state machine abstraction to design a conversation as a series of steps that the agent is taking. And each time you transition to a new state, you're summarizing the multi-turn LLM context to kind of try to take out all the information that isn't useful for the next state and just include the most accurate summary you can. You're also changing out the tools list because a tools list for an LLM actually takes up a surprising amount of context and gives you lots of opportunities to do the wrong thing when the LLM does inference. So you're trying to keep the tools list very compact. You're potentially changing the system instruction to focus the LLM on a more specific job than just the general conversation. And then you're defining what the legal next states are. So I think about a state machine as the bundle of those four things: the system instruction, the context summarization, the tools list, and what it can do next. And that turns out to really measurably improve accuracy for things like customer support workflows, where it needs to be open-ended, but you can also define subsets of jobs to be done during the conversation. And so an example of that I think might also overlap with what you were just describing is, let's say you did that authorization step that David was talking about, where it's really hard to get the alphanumerics exactly right, and the person might have had to repeat themselves to get the customer account number correct. When you summarize the context coming out of that state, you can remove the false turns. You can remove the parts where the user got the account number, or the LLM got the account number wrong. And if you just remove those parts that aren't right, you get better accuracy throughout the whole rest of the conversation because the LLM doesn't, have that wrong information in its context anymore. So that's the kind of thing we're doing a lot these days with the B2B use cases. We're doing that kind of summarization maybe 3 or 4 times during a 15-minute conversation.
I see. Interesting.
Yeah, very interesting. So Klemen, going back to your answer, did I get it right that if you feed both audios to the speech to text, and the speech to text engine would potentially have a better way of understanding the whole context of the conversation or the history of conversation, and then continue using that history to have a better transcription going forward? Is that what you meant?
Yeah, exactly. So think about it, that you would be there instead of speech to text model, right? So
I get it.
You would just hear what the user is saying. Hi, hello, I'm calling in about this.
Mm-hmm.
My phone number is 650 2460. You're just missing the other part of the conversation. So it helps a lot, right? If you have the full context, right? The full utterance context. So feeding in the TTS audio to the speech to text makes a lot of sense. Okay. So the model hears the whole conversation back and forth. Okay. At least in our case, because our models are fully conversational, right? So they very much understand who is saying when. So speakers, and if you feed in, this will immediately know this is the agent speaking. It's asking about the phone number. Now it will be able to anticipate. Okay, the agent asked about the phone number, and then the user says 650, right? This is about the, this is likely to be the phone number. It will format it correctly and things like that. So our voice are pretty very conversational aware. I mean, fully conversational aware.
Do I remember correctly that you can actually add prompts in the context as well, or is it just list of words? Can you remind me that?
Yeah, our context is a little bit different than what typically context is with other STT providers. So um, traditionally the context, right? Just for context here, traditionally the context is a list of words, list of terms that you list, and then the speech to text will boost those words to better recognize them, right? And this boosting is typically implemented through some kind of like heuristics, okay? They're not learned; they're kind of done in the decoding stage through the process of the inference. But instead, like with our new voice AI model that is unified for all languages, basically all of this is done through transformer, through attention. Okay, so the model itself, it's learned at training time what kind of words and things like this to use and attenuate and to better recognize. For example, there's no boost parameter. We don't have a boost parameter because the AI model itself should figure out, okay, when I say David, this is David, with a T, not with a D, because I provided it in the context, right? And I'm talking to David. Or if I say Klemen, I say Klemen, not Clement, the French version of it, etc. So, and it's similar goes for Quinn. So, these are, like, I would say the big difference here is just in the core of implementation of how context is done. So in one case it's like with heuristics, the inference time, while the other one is native within the voice AI model. But now, once you have this native implementation where you have transformer power, right, of doing attention, you can create your context really powerful. And that's what exactly we've done. So our context consists of 4 things. Like you can say, hey, this is going to be a conversation, about cardiology between this patient and this doctor. And you can provide past interactions, right? The entire transcription of the past conversations that these two had. You can even provide some terms like what you want to, let's say, specifically attenuate. And even if you're doing like live translation, you could provide mapping between translation pairs, to ensure that certain terms are correctly translated, because they can be tricky depending on the language. Does this answer your question?
Yeah, no, it does. I mean, you mentioned translation. Actually, the cherry on top is that the model actually also does translation out of the box to like this across these 60 different languages. I think like this is a different way of thinking about speech to text, right? I mean, it's not speech to text really. It's I don't know.
It's speech understanding. It's voice understanding.
Speech
it's understanding people speak. Yeah.
Yeah, I think that word is becoming more used, right? Speech understanding in the industry. Probably that's where the industry is going. I know that some folks are like sort of, as you were saying, Quinn, like they're sort of fusing audio with LLMs to have one model, right? So that it just understands the context and both worlds of text and audio better. And I think that's probably where the industry is going to go. And Klemen, I think like I want to congratulate you on this amazing model. We are big fans, as I said. It's very impressive. And maybe maybe it will be a game changer in the agentic, or not only agentic, but or like real-time speech to text use case. So
yeah, thanks. We're really trying to solve the real world pain problems, and make voice just as accessible as basically typing today. Yeah.
Right, very cool. Well, thanks, folks. I think this was super interesting. Quinn, thanks for coming to the podcast again. Big fan of you, obviously. And Klemen, thanks for your time. I thought this was a very interesting discussion.
Thank you. I'm a big fan of everything both of your companies are doing, so it's fun to get to talk to you in this context. I appreciate the opportunity.
Yeah, thank you both. Also, like a fan of Quinn and Daily and Crisp, so great partners. Thank you guys. Yeah.
Thanks.